Hello guys, in this part 2 of the LSTM video, I'm gonna explain you about the overview of the LSTM architecture. Before we actually get started, I wanted to tell you that I request you to watch these LSTM related videos end to end so that you will have complete understanding of the part 3 in this series where I will be explaining the maths involved. Okay, so please watch this video and the first video end to end with complete concentration. Okay, this video may be long. I'll try to have it within 15 minutes, but let's see. Okay, so let's get started. So in my earlier video, I told you why we need something else when we have a simple RNN, right? So I explained you about the problems with simple RNN, and the main problem is it cannot remember the context appearing much earlier in the time steps. Okay, so if you take a look at these two sentences here, the word guy here will decide which word to use if we are asked the model to predict it, right? So if it is singular, if it's just guy, we need it to fill with was. If there is a word guys, it's a plural, right? I want were here, right? So this is a simple example with the help of which I explained you problem associated with RNN, and RNN cannot remember whether the guy was singular or plural at this particular time step. Okay, so it may fail to fill this blank correctly. And another example I took, if we want the network to understand the story narration, okay, so here I took an example of Magad kingdom where I explained there was a ruler named Dhanananda. Later he was overthrown by Chandragupta Maurya with help of Chanakya, who served as chief advisor to Chandragupta and also to his son Bindusara. So if you look at this sentence, if you look at this story instead of sentence, earlier there was a ruler named Dhanananda, right, in the kingdom of Magad. And as we progress towards different time steps forward, we learn that he was overthrown by Chandragupta Maurya. So at this particular time step, we need to replace Dhanananda with Chandragupta Maurya as our important context. And also, apart from adding this new context, we need to have some additional context added, which is of Chanakya, because Chanakya helped Chandragupta Maurya to dethrone Dhanananda and take his throne, right? Later, Chanakya served as chief advisor to Chandragupta and also to his son Bindusara. So we need to add additional information and we need to replace Dhanananda with Chandragupta Maurya in our context space, right? So simple RNN cannot do this. Okay, so why it cannot do this? Because in simple RNN we face something called as vanishing and exploding gradients. I have explained this in my separate video, so please go back to that and watch it if you haven't seen this already. So due to the long sequences, RNN will face vanishing and exploding gradients problem, due to which it's not good at remembering the contexts which are appearing much earlier in the time steps, right? So in order to solve this problem associated with simple RNN, LSTM was introduced. So what's new in LSTM that is not in simple RNN? So we have something called as memory cell or cell state. So I'll just write it. We have something called as memory cell, or it's also called as cell state. So this we have in LSTM. Okay. So this memory cell or cell state helps the LSTM to remember the long-term context, or in other words, it helps to remember the required context at that particular time step. So this would be appropriate to say. Okay. So now for this cell state, to help LSTM to remember the required context at that particular time step, we need to have some logic in place, right? And that logic is supplied, or we can say that logic is developed with the help of three components. We call it as gates. Okay. So there are three gates in total. The first one is forget gate. Okay. The second one is update gate. This is also referred to as input gate by in the literature, I think, or most of the people will refer to it as input gate. But due to its functionality, I like to call it as update gate. Okay, you will see it in a while why I call it as update gate. There is no harm in calling input gate, and it's not wrong also. Okay, that's completely fine. And the third gate is output gate. So with the help of these three gates, we will have something updated in the cell state or memory cell that will help LSTM to understand and store the context required at that particular time step. Okay, so now if you look at this block here, this is a simple RNN block, right? So this is a simple RNN block. So it receives activations from the previous time step, it receives the input from the current time step, it throws an output activation AT at this particular time step, and if we want, we can have the predictions at this particular time steps Y hat T. So this is a simple RNN, and inside we will have our neurons associated with it. We call this as a hidden layer, right? So this is a simple RNN block, correct? So how this RNN block, simple RNN block, is modified to call it as LSTM. As I told you, we have something called as memory cell or cell state, right? So it will be running on top here. So this is just a representation. It's not necessarily to be on top. Okay. So cell state or memory cell from the previous time step, it will be input to this block, and the output will be along with the activation at this particular time step. We will also have the cell state for this particular time step. Okay. Now that I have told you about this particular thing, which we call it as memory cell, in order to calculate this, I told you we need these three gates, right? So this particular block of RNN is further divided into three sections. Okay, so this one is forget gate here, this one here is update gate or input gate, and this one here is our output gate. Okay, and as I told you, this is our cell state or memory cell, which actually stores the context, required context at this particular time step. Okay, so now what are the uses of these gates and why these are called as gates? Let's see that. So the first gate in this block is forget gate, right? Forget gate. So what it does, it helps in deciding whether to keep the context from the previous time step, whether to keep it completely or to remove it completely or to remove it partially. Okay, so that will be done with the help of this particular gate called as forget gate. Okay, so what it does, it helps to decide whether to remove completely or remove partially or not to remove at all what the cell state from previous time step. Okay, so this is the functionality of forget gate. So in short, forget gate helps to decide whether to keep the cell state from the previous time step in a filtered way, or we have to remove it completely, it's unnecessary, or we have to remove it partially. Okay, so that's what forget gate helps us. So coming to the second gate, which is update gate. Update gate, it's as a whole one thing, right? But this has three steps in it. Three steps in it. So what are those three steps? It will first compute the candidate for replacement. Candidate for replacement. So what is this replacement? Why we need this replacement? So if you can link to the story of Dhanananda Chandragupta Maurya, you would be able to relate it. So as we move in our time steps, we need to remove Dhanananda and replace him with Chandragupta Maurya. So update gate will help us to compute that. Compute the candidate for replacement, and we represent this as C bar T. So this is the candidate for replacement. Then we will have something called as update gate represented as GU. We will compute this. and then we will compute the context at this particular time step. So this is a cell state. So with the help of candidate for replacement, the update gate, and with the help of forget gate, we will compute the cell state or the memory cell input at this particular time step t. Okay. So the gate that is computed at update gate step is represented as GU, and forget gate is represented as GF. Okay. Similarly, the output gate, which is a third in the list, it is represented as GO. Okay, and what it does, it helps us to compute activation at that particular time step. And what will be the input for this? Input will be CT. By taking CT as input, which is computed in update gate step, we will compute the activation at that particular time step. Okay, so this is the theoretical overview of how LSTM is designed. Now we will go to something called as actual architecture of LSTM. Okay, so this blocks, I have copied it from the blog post, which I have given the link here. I'll also give this link in my video description. Okay, so the left side, what you are seeing here, right? So this particular step, so this thing here, this is a RNN block, right? And this thing here is LSTM. This is a LSTM, recurrent neural network. So this is a simple RNN in the left side, and on the right side we have LSTM block. So as I told you, we have one extra input, right? So if you look at this block above here, so we have an additional input here, right, which is context from the previous time step, and also we have an additional output, context or the memory cell or the cell state at the current time step. So rest remains same, and additionally we have the gates, and in this detailed diagram you can see those in detail. So this will be cell state from my previous time step t-1. This will be my activation from my previous time step t-1. This will be my input xt. This will be my output at this particular time step, or you can treat this as prediction y hat t. And here in the downside, what you can see, this is activation at this particular time step, and this particular thing on top is called as C of t. What is a C of t? This is a cell state, or also called as memory cell. Got it? Now, what about the gates? I told you, right? So there are gates as well. So this particular part here, this thing, it is forget gate. Okay, and this entire thing is update gate. Okay, and remaining thing, this will be output gate. So this is G of F, G of U, and G of O. Okay, so this is complex. I'm not lying. LSTM is bit complex to understand, but I'll try to explain it in simple terms as much as possible so that you will be able to understand it in one go. Okay, so that's it for this video, which is part 2. In my next video, I'll explain, my explanation will revolve around this particular block. What are all these funny symbols here? I'll explain it, and then I will get into in-depth mathematics involved in this particular LSTM block. Okay, so if you guys have not subscribed to my channel, please do subscribe, and also if you're liking the content, please give it a thumbs up so that it will help to reach to the wider audience. Okay, so till we see in the next video, happy learning. Bye.